Dear friends, architects, engineers, dear friends, I have shown here two number of books written by me on refrigeration and air conditioning. The first shown on left hand side was written by me about 30 years ago, published by S. Chand and Company, and then it was selling only in rupees 50, containing about 600 pages. The second on right hand side is my book on refrigeration air conditioning in SI units, uh, published by Lakshmi Publishers, by name University Press. And here this is an SI unit and most modern. Friends, let me tell you, I am life member of Indian Society of Heating Refrigeration Engineers. Dear friends, uh, before we proceed further into refrigeration air conditioning subject, it is very much essential you to know which type of system of units adopted in this particular book and this particular series or module. The SI system of units was adopted in 1972 by Bureau of Indian Standards, India. The SI comprises of a coherent system of units of measurement starting with 7 base units which are second, meter, kilogram, ampere, Kelvin, not degree centigrade or Celsius. Kelvin is the unit of temperature. Mole, that means amount of substance, and candela, used in luminous intensity. Friends, this describes a temperature system. Uh, what are the changes adopted in SI system as compared to MK system previously prevailing? Now temperature is Celsius, not centigrade. Zero temperature occurs at 273.16 in Kelvin instead of 273.15 Kelvin previously. Pressure unit is Pascal, scientific, or kilopascal, and for engineers it is bar. 1 atmospheric pressure is equal to 14.7 psi of FPS system, 100 kilowatt, 100 kilopascal equal to 1 bar engineer's unit, 10 meters of water head, and 760 mm of mercury gas. HP adopted is metric HP, which is equal to H into Q whole divided by multiplication of 75 into efficiency, mostly used for pumps. Friends, this chart describes all types of mechanical refrigeration systems. Let us take central air conditioning system. In this, there are two type of systems in central: ductable package type are central plants. Injectable package plants which are available only up to 17.5 ton. There are two type of systems: air cooled ducted splits or floor mounted package air conditioner. And the floor mounted air conditioners can be air cooled or water cooled. In this central plant system, we we have three choices: VRF, variable refrigerant systems, which goes up to 40 tons. Then direct systems, DX, known as, they are available up to 120, this one. And then beyond this, the chilled water system, which are available after 120 tons to 2000 tons. And chilled water systems are maybe vapor compression type or vapor absorption type. Vapor absorption type is a silent system. Vapor compression system further gets classified into one, reciprocating uh, air and water cooled systems. Second, centrifugal units, mostly water cooled, and screw type units, air and water cooled. In the vapor absorption system, we have direct fired, hot water fired, or steam fired single and two stage. Now we go into non-central AC system, which are known as unitary system also. They are available in window air conditioner category. These are up to 3 tons. Then a split air conditioning unit, which gets divided into floor mounted, wall mounted, or ceiling mounted. And ceiling mounted unit may be exposed type, concealed type, or semi concealed type. All these are available only uh, restricted tonnage. Okay. Friends, the two of main components of central air conditioning systems are condenser and evaporator. Evaporator, otherwise known as chiller in case of chilled waters, this one. All these two are simply heat exchangers. And the heat exchanger of simple cell and tube type is shown here, in which one fluid enters and takes a long route provided in uh, the cylindrical type of system, in which there are two headers, and all internal tubes get connected to these headers. So let us come back. One fluid enters, say refrigerant, through this and takes a long route, and due to baffles provided in the cylinders. These are half cylindrical baffles. The fluid, say refrigerant, comes out, and in the this long circuitry of tubes connected through header, uh, water flows. So there are two things: refrigerant as well as water. they exchange their heat and perform the function. This entire thing is known as a cell. Friends, this table describes uh, the temperature to be maintained in the room or enclosed space, and the third is now gives the refrigeration temperature to be maintained. The first one is central air conditioning processes, of which first is comfort air conditioning, and it requires a enclosed temperature to be maintained of 20 to 25 degrees Celsius through refrigeration temperature between 0 to 10. For cold storage applications, we need plus 5 to minus 5 degrees Celsius temperature to be maintained through refrigeration temperature of minus 10 degree Celsius. Then comes the process of domestic refrigeration, fridges. Here we are supposed to maintain a temperature of minus 5 degree Celsius, and refrigeration temperature may be minus 15 degree. For food preservation system, we need temperature of minus 15 to minus 25 to be maintained through refrigeration temperature of minus 35. And next category is freeze drying. And in freeze drying, we need temperature of minus 25 to minus 30 degree to be maintained through a refrigeration temperature of minus 35 to minus 45. Friends, this is a very important diagram which shows general refrigeration circuit for a particular refrigerant in window type air conditioner. Several concepts will be explained here. First of them is that the media which interconnects all the important units of a refrigeration air conditioning system has got four essential components. First is the evaporator, second is the compressor, third is the condenser, and fourth is the expansion valve. This particular diagram is for window type air conditioner using a particular refrigeration type R22. I'll explain little later, but let us understand how these components work together and what is the implication. First of all, the refrigerants in vapor stage is shown by this blue color, and refrigerant in condenser when it is condensing is shown by red, and this color shows the combined liquid plus vapor state of the refrigerant. Now, one more concept I want to introduce here is that this entire refrigerant circuit works on two different two different pressure systems. The pressure system, the refrigerant system on right of this line is low pressure system, and this system on left hand side is high pressure system. The pressure is incorporated through compressor. In compressor, electrical power is applied to for working of compressor, and when the gas is compressed, it is sent. Its temperature is enormous, so it is sent to condenser for condensing the refrigerant temperature and bring it back to expansion valve where we reduces the pressure. So whatever pressure is increased here by compressor in up to this circuit is reduced by expansion valve in this part of circuit. Uh, there is one more concept which is known as refrigerant effect. Say if we have this coil is inside a particular room, enclosed room, which is getting air conditioned. So the coil absorbs heat from the room, and all persons sitting in the room, all material is stored in the room, and the temperature of refrigerant gets increased. Here it is roughly 4.4 degree Celsius, because water cannot work at lesser temperature than that. And this heat absorbed here by the cooling coil from the room is known as refrigerant effect. And this effect is here the heat exchange is of the order of 4.5 times of the heat added in the compressor 1 unit. If it is the electrical motor added heat into through compressor system, and if that is of one unit, the refrigerant effect created is 4.5, whereas on the condenser side the heat rejection is 5.5 times. So the condenser coil has to be bigger size as compared to evaporator coils, cooling coils. That is the question which is asked in most of this one, the examinations. And this ratio, COP, coefficient of performance, is equal to refrigerant effect divided by the electrical power. So here it is 4.5 this divided by 1, this is refrigerant effect. Since transfer is in condenser equal to 5.5, this is known as heat rejection factor. So all basics have been explained through refrigerant circuit of a window type air conditioner. Friends, once again the same refrigeration circuit used by window type air conditioner using R22 refrigerant. But here I have given the temperature and pressure. Let me start from here. The liquid enters refrigerant in partially liquid and vapor state, enters the evaporator coil at temperature 5.1 degrees Celsius, where after heat exchange its temperature is increased to 10.7 degree. This now we come to this stage. In this portion, the temperature for this particular refrigerant, the pressure is 5.9 bar. That means 5 times 9 times approximately equal to atmospheric pressure. Now the condenser increases this pressure from 5.9 to 19.3 bar for this refrigerant R22. This happening due to addition of power by electric motor, and that power is taken as 1 here. After when the gas refrigerant is compressed, its temperature is increased to 19.3 degree, and also the temperature, which is 88.6 degrees Celsius. So the purpose of condenser is to reduce this 88.6 degrees Celsius to 43.3 degrees Celsius for this particular refrigerant. All these figures may be different if the refrigerant is different. After the temperature has been reduced by the condenser through circulating wire cold water from cooling tower, the gas goes in expansion valve where the pressure is reduced from 19.3 bar to 5.9 bar. So the purpose of expansion valve is to reduce the pressure. So this is all regarding temperature and pressure of different components in the air conditioning circuit. Friends, in this particular schematic diagram, I have shown all the major components as they physically look like. So let us take evaporator. Evaporator is nothing but a combined cooling coils, and then compressor. Compressor is a sort of cylindrical container. The third major component is condenser, and condenser is once again a system of many coils. Now these coils may be in copper or maybe in aluminum. So from condenser, the refrigerant comes out and exchanges its pressure through expansion valve. That means it is something like the pressure cooker. Here the pressure is reduced and the refrigerant comes once again here. Now here it is in vapor and liquid form, and evaporator converts it into vapor form, and this vapor is condensed, the vapor is pressurized through a compressor which adds heat also temperature increases, and the uh, function of compressor is to reduce the temperature. And here also we have a fan which interacts with the outside atmosphere, and here also we have a fan system which works inside the enclosed atmosphere. This particular figure shows a layout of evaporator coil or cooling coil. In the cooling coil, a number of coils are there of copper, and these coils get cooled through finning system provided in the coil, evaporator coil. I have shown the cooling coil which is like this, and here, and this finning, these are aluminum fins mounted on copper or aluminum, this one, so that these coils get cooled through this increased area provided by the aluminum fins, which is shown here also. This is the refrigerant line. Fins have been removed here, but these are the end view of cooling coil, and this is the cooling tube, and these are the area, increased area here.